Hi, I'm an old guy and I do maths, and we have an interesting problem today. This is referred to me by a student who asked me if I could solve it for her. Um, I had a bit of a look at it and I played around with it, trying to think of the simplest way to deal with this, and I came up with what follows. So let's go to work. Now, we are told that we have a function in this form, a log in base 2 of x plus b, and that there are 2 points on this function that we know, 8 and 10 and 32 and 14. Now, if you were to pop this on a bit of graph paper, you'd see that you could make this conform to a pretty standard logarithm graph shape. A sort of a gentle curve that gets steeper and steeper as you approach some sort of asymptote. Whether the asymptote in this case is the y-axis, it's likely that it is. I can't think why it wouldn't be. Anyway, let's get to work. We're not actually interested in the graph, we're interested in the function. So, things that we know. Well, we can write this function out in two ways. A of log in base 2, and we can take this 8 of 8 plus b is equal to 10. That's what this combined with this tells us. We can also say that a times log 2 of 32 plus b is equal to 14. And the keen-eyed amongst you might think that this is wonderful grounds for work with a simultaneous equation, but I think that probably there's a better way into this. Now, what I did to get the correct answer was I took this part of each function and worked out what it was equal to. Now, that's not particularly difficult. I'll do that here. Now, if you don't understand why these two expressions are equal to these two numbers, maybe take a step back. But what this says is that if you write this out as an exponential, 2 to the power of 3 equals 8. So this part of this function is equal to 3. And this part of this function is equal to 5, because 2 to the power of 5 is 32. Now, what else can I do to help myself here? Well, I can rewrite one of these. I've chosen to rewrite this, and I'm going to keep the log expression in here just for a moment. So, as you can see, I've slightly rearranged this. Very slightly rearranged this. Now, I can take this value here, 3, and place it in here instead of log in base 2 of 8. So I shall do that. And what I get is a times 3 is equal to 10 minus b. And from that, I can deduce that a is equal to 10 minus b over 3. Now, how does that help me? Well, what it does is it means that if I take this expression for a and, for instance, I put it into this expression, what I've got is I've got an entire expression where I've got some sort of value of b, and that is extremely helpful. So let's do that. Let's take this, and I'll do this with the log expression in place first of all. What do I need? I need 14. No, plus b equals 14. Get it right. Okay, so now I'm going to rewrite this as this times this log expression, which is a. So log 2 of 32 plus b equals 14, and I'm going to multiply that by 10 minus b over 3. So that stands in for a. I know that this has a value because I've figured that out up here, and so I'm getting to the point where I can write 10 minus b on 3 times 5 plus b equals 14. Well, let's get some more paper. We're going to need a little bit more paper. So I had got to the point where I had an expression 10 minus b on 3. I hope I said b for that, not 6. My b's and 6's are very, very similar, and sometimes I even get confused. That should be 10 minus b on 3 times 5, which is the equivalent of this expression here, plus b equals 14. Right, so I'll just rewrite that at the top of this page and continue my working. So 10 minus b, emphatically b, times 5 plus b equals 14. So what does that give me? That gives me 50 minus 5b over 3 plus b equals 14. You can choose how you go about dealing with this, but I'm just going to get rid of the denominator, which gives me 50 minus 5b plus 3b equals 3 14s are 42. Okay, so 50 minus 2b, yeah, 2b equals 42. Tidy this up. 2b is equal to 50 minus 42. b therefore is equal to 4. 50 minus 42 being 8. 2b equaling 8 means that b is equal to 4. I have found, I hope, well I know because I have checked the answer, I have found the value of b. Now, the next thing I have to do is to find the value of a. And again, this is just, I suppose, an object lesson in doing what you can rather than becoming obsessed with the order of things. I found the value of b first. A, according to my previous working, is equal to 10 minus b on 3. Right. 10 minus 4 over 3. 10 minus 4 is 6. 6 over 3 is equal to 2. That is my answer for A. So, A equals 2, B equals 4. Thank you very much for watching. I hope that you found this useful and that it made sense. The path through logarithms is not necessarily easy. and it often involves a little bit of trial and error, just to see which way of approaching a problem works best. That was certainly the case here. Anyway, that's it done, and that's how it is done. Thank you very much for watching. If you found this useful, please like and subscribe, and I will see you next time. Bye.